my class 10 students, I hope you all are doing great. Today I have brought you a very important video, that is most important numericals of physics for your class 10th boards. Now I know we all are little bit scared because CBSE has increased their levels, it seems. But these are the kind of questions that we have seen being repeated every year. Plus, if you do these kind of questions, I think you are capable of doing all the hard questions as well, because this clears your concept, right? So let's dive into the most important numericals of physics for your science exam, that is on 25th. Okay, let's move on. The first we have a very important concept, that is stretching of wire, how resistance changes as the wire stretches. We know it, this question has been repeated again and again in the PYQs, in the past question papers, in the sample papers as well. So let's look into this, how to approach this question, right? If the length of wire is increased by 20% by stretching, so the length of my wire is increased by 20%, that too by stretching, calculate the percentage change in its resistivity and resistance. How to approach this question? See, before the stretching, the length of the wire was something. Let's take before stretching, let's write it BS, that is before stretching, the length of the wire L1 was simply L. Right? After stretching, now what happens? The length of wire is increased by 20%. Say, this was my wire, that was L. Let's say now the length of the wire increased, something like this. So this increased part, how much it got increased by? It got increased by 20%. So this extra part will be 20% of this length. So the whole length will be what? L, that was original, this one, this L plus 20% of L. Very simple, basic, nothing rocket science in this. So L2, now after stretching, L2 will be simply L1 plus the stretched length plus the stretched length, right? L1 is simply L plus stretched length is 20% of L. Correct? Understood? Very basic. This is how you approach these kind of questions, right? So now L1 is simply L. The area was simply area, because we have to find resistivity and resistance. Now I know that resistance is simply rho L by A. Now ma'am, even my soul knows this formula, right? So length for R1, that is before stretching, length is L. A1, area of cross section is A, right? And what else do we need? Resistivity, rho 1, let's say simply R. Now tell me one thing, this is very basic, we have studied all through the year, that if the same wire is stretched, the wire remains the same, material of the wire remains the same. If material of the wire remains the same, resistivity remains the same. So rho 2 will be simply rho. So in this question we have already answered one thing, that is percentage change in resistivity. There is no change in resistivity, that is 0%, right? Only thing left is resistance. Let's look into that. Now for R2 resistance after stretching, we have L2 as what? L1 plus stretched length, right? That was what? L plus 20% of L, right? Everyone? Correct. So L2, now we can solve this. L2 is L plus, can I write 20% like this, 20 by 100 into L, right? I'll take the LCM, that is 100. So this will be 100L plus 20L, right? That will be 120L divided by 100. So this 0 cancels out. This becomes 1.2L. Understood? So L2 for R1 comes out to be rho L1 by A1, that is rho L by A. For R2, L2 comes out to be 1.2 L, right? L2 comes out to be 1.2 L, and since we know it is stretching, very important my kids, when it is stretched, length increases, but we know area of cross section decreases. So A2 is decreased by the same amount. A2 is A1 divided by 1.2L. Now A1 we knew, it is simply A. A1 is simply A. So I can write A2 as A divided by, no, not 1.2L, only 1.2, right? This is 1.2, right? So R2 becomes what? R2 becomes rho, because resistivity is same. Rho L is 1.2 into L, right? Divide by A2. A2 is A divided by 1.2, right? If I take this LCM, this lower term above, it will be rho into 1.2 into L into 1.2, right? And down there will be simply A in denominator, correct? Now if you solve this, this will be simply rho 1.2 into 1.2, 12 square. Very easy, we learned it even in 8th, 7th, 8th, right? 12 into 12, 144. And there are 2 points. So 1.44 divided by into L, we have one L here and one A here. Now we have to calculate change. We have R1, we got R1, and R2 comes out to be what? This. R2 comes out to be 1.44 rho L by A, correct? This is clear. So R1 and R2 here. How do we calculate percentage change? Don't forget to calculate the percentage change. I have done this mistake when I was in school. I used to just tell the answer here and write answer R2 equals to this. No, you have to complete the answer, that is percentage change in resistance. Percentage change in resistance, that is what? The formula is R2 minus R1 divided by R1 into 100, since it is percentage, right? Now R2 is what? R2 is 1.44, that is 1.44 into rho L by A, minus R1 is simply rho L by A, and in denominator we have rho L by A, right? Any doubt? Very easy, correct? Now see how I am putting them in brackets and they are very neat and clear. So in presentation you have to show this. In paper you have to present your numerical very carefully, very neatly. So write it exactly like this. Now take this rho L by A common. Can I do this? 1.44 minus, if I take rho L by A common from the numerator. So what will happen? 1.44 minus 1 divided by rho L by A. It is still here, correct? This cancels out. This cancels out, same term. So 1.44 minus 1 into 100 into 100. So that is simply 0.44 into 100. That is 44. So percentage change in resistivity is 44%. At the end you have to write that percentage change in resistance will be 44%. Okay, done. Very difficult, I won't say it's a difficult question, but very unique question. The length is stretched, so the stretched length is added into the previous length, right? 20% of L is not the new length. L plus 20% of L is the new length, correct? Okay, before moving on to the next question, I have a very important thing for you. This is a PDF that I made personally with all the formulas: see electricity, light, human eye, as well as magnetic effects of electric current. All the chapter formulas are there in just one video, in just one PDF, one single sheet. What you have to do, go click the link there is in the description, fill your mobile number, get the OTP, continue, and you will get the PDF. That's it. That's simple. Get that PDF for free. There is no cost for all my kids. Go check that link, check that description, and ace your board's examination. Okay, moving on to the next question. Let's move on to the next question. We have combination of resistances, right? Sorry. What is the equivalent resistance across A and B in the figure if R equals to 3 ohm? How do you approach this question? As soon as you get a question which is combination of resistances, what do? You find a circuit that is, let's say, first step is to find a circuit that is in series. First, find a circuit that is in series. Now, is these R1, 2, 3, 4, 5. Okay, named them. Is R1 and R2 in series? Ma'am, R2 and R1 we can say it in series, but from the same point one another resistance is there, so they are not in series. Another R3 and R2, okay, but some other resistance is still there, again not in series. R5 and R4, they are these, between these two points only one resistance is there, then between these 2 points only one resistance is there, so aren't these in series, right? Aren't these in series? So first you have to do, ma'am, 5 and 4 are in series. So let me find their equivalent resistance. So R5 4 will be what? R of 5 plus R of 4, right? R of 5 all are 3. So 3 plus 3, that is 6 ohm. So R5 4 is 6 ohm. Now step 2, very important. You have to recreate this diagram. Why? Let's do that in rough work. Even if you don't want to do it like perfectly, spend so much time on it, do it in rough work. Sketch a line here and do a rough work. Okay, so I sketched a line here. Now what will be the new resistance? You don't have to make them now very neatly, just make it very, not like this, just make it how with your pencil. Okay, now this is the new resistance, this is the new combination of resistor, this is the new diagram. So this is R1, R3, R2, and now this one is what? This one is the new one we found, R5, 4, and this is equal to 6 ohm. Right? All these are 3 ohm, 3 ohm, 3 ohm, 3 ohm. This is 6 ohm. Now see carefully, R5, 4 and R2. R5, 4, this becomes something like this. This becomes something like this, R5, 4. Now R5, 4 and R2, those are in parallel. Clearly see, those are in parallel. So let's put a parallel combination formula of that here, right? So R2 and R5, 4, R2 and R5, 4 are in now parallel, right? So what is the formula of parallel? 1 by RP, let's write it P, P1. Okay, that will be 1 by R2 plus 1 by R5, 4. Now 1 by R2 is, ma'am, that is my 3 ohm, the given one. 1 by 3 plus 1 by R5, 4. R5, 4 is 6 ohm. Don't forget to write 6 ohm, right? So 1 by 6. I'll take the LCM as 6. This is 2 plus 1. 3 by 6. That is 1 by 2. If I cut it, so RP1 will be what? RP1 will be simply 2 ohm. Simply 2 ohm, right? Let's again make the diagram. Again in the rough work, because I don't want to make it very clearly. Just mention that this is a rough work. Wherever you are doing the rough work, mention that this is a rough work. It is genuinely advised to sketch a line on the right hand side of the sheet and write it there. Okay? Okay. Now rough work, RP1. What is the diagram now? This is the diagram. The diagram, this diagram got converted, this whole big diagram got converted into just these, because we solved this parallel connection, right? So this diagram got very small. Now this is the diagram, this is 3, but this is 2. Okay, now these are in series. Ma'am, now step 3, R1, R3 and RP1 are in series now, right? So I will simply add them. So equivalent resistance will be R1 plus R3 plus RP1, that is, this is 3 plus 2 plus 3, that is 8 ohm. Done. The equivalent resistance comes out to be 8 ohm. Don't forget the units. If you simply write 8, you will get 1 marks cut. Units are very important. Done. Move on to the next question. Next question, again we have a very important circuit. I'll solve half of it because it's very easy. Okay. we have to find the current flowing through the given circuit. Now in this given circuit, I told you to find the easiest circuit, I told you to find the series circuit, but here there is no series circuit. So what will we look for? We'll look for parallel circuit. Of course, one more thing, we have the series circuit. This 1 ohm, this 6 ohm are in series, but in between them we have a parallel combination. So if I solve these two, it will become 1 and all three will be in series, right? Very easy. So I'll solve this combination first, right? So let's say this is 1, this is 2, this is 3, this is 4. Let us solve 2 and 4 first. First step, 2 and 4 are in parallel. They are in parallel, right? So 1 by Rp1 will be 1 by R2 plus 1 by R4, right? So this is 1 by 2 plus this is 1 by 2, that is simply 1 ohm. So Rp1 this is 1 ohm, right? Now if I have to make a circuit, where will I make it? In the rough space, in the rough space. Why? Because I don't want to make a neat circuit, I just want to make something like this, okay? So because if you make it here, you will have to complete it, you will have to write 4 volt, a key and all that stuff. We don't want that. This is 1, the new one is 1 and this is 6. So these are in series. Now second step is to find the equivalent circuit. Equivalent circuit will be what? R1 plus Rp1, because this got converted into Rp1, that is Rp1 plus R this 3, right? Now R1 is 1 ohm, Rp1 is what? Rp1 we found is also 1 ohm, plus R3 is 6 ohm. Again we got an answer 8 ohm. Now what is left in this question? Find it. See, in the last question we have to find what is the equivalent resistance. In here we have to find the current flowing through the given circuit. So make sure you are reading the question very carefully, right? Actually we discussed that you have to write given. So whatever is given in the question, it is in the diagram. To find in this question, we have to find the current, and this whole is the solution. Done. So what is the current we have to find, right? Voltage is given, that is 4 volt. Equivalent resistance we found out, that is my 8 ohm. So now by using V equals to IR, can I easily find the current? Current I have to find, resistance is given, volt is 4, current is, you comment down, okay? What is the current? For slide number what? We have the slide number 8. Okay, I'm telling you, solve these questions. There are high chances that these kind of questions can be repeated, or if a difficult question comes, you can use these basic concepts to solve that, right? Okay, let's move on to a very important topic of the question, that is how is electric current related to the potential difference? That is very easy, ma'am. V equals to IR. We'll do the revision quickly. Second, this graph, there are high chances that this can come. Lots of questions in the PYQs, lots of questions in the sample paper, and expected questions are given by the CBSE. Okay, so first understand this graph. This is a VI graph. The slope of VI graph, gives what? It gives R, that is resistance. So you need to follow 3 steps. First step is find the slope. Find the slope of graph. Ma'am, slope of graph is R. No, not every time. Find the slope from this. From math, we know that slope of graph is y-axis, component of y-axis divided by component of x-axis, right? So let us find the slope. Understand it very carefully. Let us find the slope. So on y component we have v, x component we have I. That means slope comes out to be v divided by I, right? Second step is to find R, but from Ohm's law. What do we have to do? Ma'am, Ohm's law is V equals to IR. This much we know. From here we have to find R. Just rearrange it. R is V divided by I, right? So that is equal to slope. We just found out. Now slope becomes equal to r. Slope becomes equal to r. Correct? That means if the slope is more, r is more. If the slope is less, r is less. Right? If slope is more, r is more. Slope is more, r is more. If slope is less, r is less. Right? Now why did we study this? What will happen more r, less r? That's when we read the question. Two VI graphs A and B in series and parallel combination. Series and parallel combination of two resistors are as follows. State which graph. This is, let's say, A graph. This is B graph. Which graph shows the series and parallel combination? Now, we should know that in series the resistance is more or in series the resistance is less. That is, my friend, here ma'am, we know that in series resistance becomes more. Why? Because it adds up, right? In parallel on the other hand, series is minimum. That is, it's less. It is minimum because we take LCM. Sorry. Done. So if slope is more, that means out of A and B, whose slope is more? Slope of A is definitely more than slope of B, right? So slope of A is more than slope of B. So that means, ma'am, resistance of A will be more than resistance of B because here we slope is equal to R. Right? If slope is more, the resistance is more. Now for more resistance, this is a series combination. So this is series, that is A, and this is parallel, that is graph B. Understood, everyone? If you have any doubt, let me know in the comment section. Okay? A second part is, why should an ammeter have low resistance? This is the question we have studied lots of times. Why an ammeter should have low resistance? Because it is connected in series with the circuit, with the resistor. If it is connected in series, that means current will divide. That means, current will be same. That means whatever the current is going through the resistance, the same current will be going through the ammeter. And if there is a current drop, if there is a resistance provided by the ammeter, the current will drop. The current will drop and it won't measure the actual current that is passing through that whole circuit. That is why ammeter resistance should be lowest, so that current value in that shouldn't be affected. Right? It's getting hot in here. Okay. Let's move on to the next question, on to the chapter light. An object 4 centimeter in size. So height of an object is 4 centimeter given. What do we say, kids? We say that we write as we read the numerical. So height of object is 4 centimeter. Place that 20 centimeter. So U is 25 centimeter. 25 centimeter, and U is always negative, right? In front of concave mirror. We are given concave mirror, right? Of a focal length 15 centimeter. Focal length is 15 centimeter. As we write focal length, what do we have to decipher? We have to decipher its sign. For concave mirror, focal length is negative. Focal length is always negative. At what distance from the mirror? Now this is my given, right? This is all the information that is given to me. We have to find. What do we have to find? At what distance from the mirror should a screen be placed? If I have to find the screen distance, that means I have to find the image distance. So I have to find V. Should a screen be placed in order to obtain a sharp image? Find the nature and size of image. We also have to find nature and size of image. Done? We have written given, we have written to find. Now, the next thing is our solution, right? You don't have to hit this line. You just go below this in the answer sheet. Okay? Now, what do we use to find V? I have F, I have U. I can simply use mirror formula. Right? So, mirror formula is what? 1 by F equals to 1 by V plus 1 by U. So 1 by F 1 by f is minus 1 by 15. Don't forget the minus signs. 1 by v we have to find, plus u is also negative, that is minus 25. Right? We have to find v. I'll take this u in here, minus 15. This is minus. When it comes here, it will become plus. Right? Very easy, very basic math. So the LCM, we can take the LCM as 75. Right? So take some kind of number which goes with both. That is the basics of LCM. So 15, 5 is our 75, and for 25 it is 3. That is 1 by v. Now this comes up, minus 5 plus 3, that is minus 2 divided by 75. It comes out to be 1 by v. So v comes out to be minus 75 divided by 2, that is 37.5 centimeters. Understood? Sorry. Done? Okay. Next we have to find the nature and size of the image. Now nature, see, v is negative. The nature I can also decipher from magnification. For mirror, magnification is minus v by u. Right? Now minus v is minus 37.5, divide, right? And u we have a minus 25. So this cancels out. This comes out to be 1.66, I guess, something like this. So this comes out to be minus 1.67. Right? Correct, everyone? Done. Now we got magnification. Magnification is negative and more than 1. So magnification, the nature of image, from negative sign we can decipher that it is real and inverted. It is real and inverted, right? And for size now we have magnification, height of object. We know the formula of magnification is also height of image divided by height of object. Height of object is 4 centimeter given. Height of image I have to find. Magnification I just found out. Can we easily solve this? Can we easily solve this? Right? Correct, everyone? So just solve this, just multiply these two. Height of image equals to 1.6 into 4, that comes out to be 6.4 centimeter height of image. Whatever this is, I think this is 1.5 something maybe. Whatever this is, solve that. Okay? Done? Easy. I didn't forget units anywhere. See? In here, magnification doesn't have a unit. Minus 37.5 centimeter, 6.4 centimeter. Everywhere, even in the given, even in the to find, you have to write all the units. Okay? Okay. Let's move on to the next question. Light enters from air to glass. This is air and this is glass, my friend. Right? Light is entering from air into glass, having refractive index 1.5. So refractive index, now this value is of what? Sorry. This value is of glass with respect to air. So refractive index of glass with respect to air, that is 1.5. What is the speed of light in the glass? We have to find speed of light in glass, right? This is to find, this is given. Right? Now the speed of light in vacuum is also given. So speed of light in vacuum is given as 3 into 10 raised to power 8 meters per second. Done? Okay. Now this is very easy, ma'am. We know the formula for refractive index. N12 equals to N1 divided by N2. That will be equal to V2 divided by V1. Done? Understood? So can I apply that here? N of GA is given. N of GA equals to N of G divided by N of A. That will be V of A divided by V of G. V of A divided by V of G. Now you can solve this, right? This is simply 1.5 equals to V of A is also given. 3 into 10 raised to power 8 meters per second. And this is V of glass. We have to find. Comment down the answer in the comment section. Okay, answers for everyone, answers are in the comments by my very sweet kids. Okay, slide number we have 13. Okay, write down answer as slide number 13, answer is 5 or 2 or 3. Okay, done. Let's move on to the next question. We have, if the image formed by a spherical mirror for all positions of object, in front of it is always erect and diminished. They are saying that the image formed by a mirror is always erect. Now, what type of mirror is it? Draw label diagram. Now, you tell me what type of mirror is it? The mirror that always forms erect image. Is it a concave mirror, convex mirror? Now, if I have to tell the answer to you, I don't think I've done my work right. So, you tell me in the comment section right now, slide number 14. Slide 14, answers in comment. Okay, which is this mirror? Then draw a label diagram to support your answer. Okay, now I think you have written your answers. This, my friend, is a convex mirror. This is a convex mirror. We know that, right? Because convex mirror is the only mirror that forms virtual and erect image always. Now this is my convex mirror, right? If I have to make a diagram of the convex mirror, what will I do? I'll make a convex mirror first, obviously. Then I'll make a principal axis. Anywhere between infinity and pole of the mirror, I'll make my object. Something like this, right? Now, a ray will go parallel and will appear, it will diverge, but it will appear that it is passing from the focus. It will appear that it is passing from the focus, right? The other ray, on the other hand, this is center of curvature. The other ray will feel like it is passing from center of curvature, and we know, just make this a little bit correct, and we know that the ray that passes from center of curvature goes through the same path. So again, it will get diverged back to the same path, and this, my friend, this arrow on the other side of the mirror, mirror will be my image. Done? Very easy. Okay, let's move on to the next question. Our next question says, another chapter, an electron enters a magnetic field at right angles to it. An electron enters a magnetic field at right angles to it. This is the magnetic field. As shown, the direction of force acting on the electron will be. We have to find the direction of force. Now, my friends, my kids, what rule do we use to find the direction of force? There are two rules, right hand thumb rule, Fleming's left hand rule. Now from Fleming's F, we know force, F. So Fleming left hand rule is used to find the direction of force on a current carrying conductor or a charge moving in a magnetic field. This concept is very important. A very important formula is QV cross B. That gives what? QVB sine theta, right? This is one of the most important formulas of your chapter, magnetic effects of electric current. Now, B and V, they have sine theta. Now, if it is entering in the right angles, that means theta will be what? Theta will be 90 degrees, right? Now, I have to find the direction of force acting on the electron. Now tell me one thing, if electron is downwards, the current will automatically be upwards. And Fleming left hand rule says what? If I stretch middle finger, index finger and thumb of my left hand, the index finger will point in the direction of magnetic field, that is this. The middle finger will point in the direction of current, that is upwards. The force, the thumb will give the direction of force. This is like this, magnetic field, current, upward direction, force, thumb, force, right? That is inside the plane, that is into the page. Done? These kind of questions will be asked, will definitely be asked in your exam, okay? Next, we have near point of the eye of a person is 50 centimeter. As we read, we write. What is given? Near point of eye is given. That is 50 centimeter. Find the nature and power of the corrective lens. We have to find the nature and power. Nature and power of what? Of corrective lens. Right? This we have to find. This is so to find and this is given. Correct? So given to find the nature and power of the corrective lens required by the person to enable him to see clearly the object placed at 25 centimeter. Now, how to decipher what is U and what is V? Right? And what do we have to find? We have to find the nature of power. So, nature and power. How do we find power? Focal length. For focal length, we should know U and V to put in the lens formula. That's how you think. Right? Now, on to the solution. Let's see. First, what you have to decipher, every time you are given a question like this in which it is mentioned the near point or the far point, no matter what it is, either it's near point, it's far point. The new near point that is given will always be the image distance, will always be the V of the corrective lens. Now V, that means of the corrective lens, will be 50 centimeter and it is always negative. Doesn't matter it's a concave mirror, concave lens, convex lens, it is always negative. Right? Now U, so this 25 centimeter is the actual distance for the near point for a normal human eye. So that means they are saying that object is at 25 centimeter, but your eye can only see the objects that are placed at 50 centimeter. So what your corrective lens has to do, it has to make the image of that object at 25 centimeter at 50 centimeter first, then that object will make an image in my retina, in my brain. Done. So the work of this corrective lens is to make the image of the object at 25 centimeter at 50 centimeter. Understood? Okay. So again, this is corrective lens. This is again U is always negative, minus 25 centimeter. Now can I find focal length easily? So by using lens formula, I will write 1 by F equals to 1 by V minus 1 by U. F I have to find, V I have V, that is minus 50 centimeter. Minus 50, U is always minus, that is 25. I'll just take the LCM. This is the easiest calculation to ever exist. 50 minus 1 plus 2, that is 1 by 50. So focal length will be 50 centimeter. Focal length is positive. Focal length is what? Focal length is positive. That means which lens has positive focal length? Convex or concave? We know concave has always negative, so this is a convex lens. This is a convex lens as focal length is always positive. Done. So nature we wrote, right? Nature is convex lens. Correct? Then we have to find the power. For power, the formula will be 100 divided by focal length if focal length is in centimeters. So for power equals to 100 divided by focal length is here is 50, right? So power will be 2 diopter. Very easy. You just had to decipher what is the near point, what is the V, what is the U. Done? Okay, let's move on to the next. The far point of a short-sighted person is 1.5 meter. See, the same question. I told you the far point or the near point, whenever it's given, the given far point 1.5 meter will always be what? It will always be V. It will always be V of the corrective lens. Given is far point, which is 1.5 meters. Now this far point is my V, that is 1.5 meters, and it is always negative. Find the focal length. We have to find the focal length and power of the remedial lens. Remedial is also the corrective lens. So see, now U is not given. Right? Sorry, U is not given. So what will be the U? you will be, what is the normal far point of a normal human eye? That is infinity. So what this lens is trying to do, it is trying to make an image that is at infinity at the far point of that person, at the far point of that person, which is 1.5 meter. Okay, done. So u is infinity. Now it is negative, positive, doesn't matter. So I have to find power. Again, the solution formula, write with proper presentation. Formula is lens formula, right? Lens formula is what? 1 by f equals to 1 by v minus 1 by u. 1 by v is what? 1 by v is minus 1.5. 1 by v is minus 1.5 minus this is just infinity, focal length. 1 by focal length is minus 1 divided by 1.5. This will become 0. So 1 by focal length will be not. Let's just write simple focal length. Focal length will be minus 1.5 meters. Which lens have negative focal length? That is, ma'am, my concave lens, right? That is concave lens has negative focal length. Now power will be 1 by focal length when focal length is in meters. What is the focal length? That is 1.5 and negative. So power will be 10 by 15. Solve it. Whatever comes, that is your answer in diopters. Done? Sorry. Done? Understood, everyone? Okay. Let's move on to the next. We have a force experienced by a current carrying conductor placed in a magnetic field is largest when the angle between the conductor and magnetic field is. So first we have to find the force. The force, we are given that force is largest, right? Force is largest. Force experienced by a current carrying conductor placed in a magnetic field is the largest when the angle between conductor and magnetic field. See, this is conductor or something and this is magnetic field. When will the force be largest? Ma'am, we read a very important formula, that was QV cross B, right? And this was QVB sine theta. Now this means that force will be largest when sine theta is largest. Sine theta is maximum, right? Now when, for what value of theta sine is maximum? That is theta equals to 90 degrees, sine theta is maximum. That is the option C, 90 degrees. Done. And here we are done with almost all the important questions of all the physics. Sorry. We completed light, human eye, electricity and magnetic effects of electric current. Make sure you do these kind of numericals and more stuff like this when you are practicing, when you are self-studying. But these numericals are the ones that you should not miss at all. Even if there is a tougher question, these numericals will make a base for you. From the starting line you can go above, right? Okay. Practice for this and all the best for your examination. Bye.